There are 7 different payloads on Aditya mission, and one of them is the Solar Ultraviolet Imaging Telescope. So this instrument is going to image the sun in near ultraviolet. There are 7 different payloads on Aditya mission, and one of them is the Solar Ultraviolet Imaging Telescope. So this instrument is going to image the sun in near ultraviolet. That is what we have built here at IUCAA under the leadership of IUCAA, Professor Ram Prakash and myself. We led the team. Of course, we have had various important contribution from ISRO. A lot of components were given from ISRO. Of course, the specifications of those components were identified and defined by us, our team. In addition, this payload also has contribution from Center for Excellence in Space Science and Indian Institute of Astrophysics, Manipal Academy of Higher Education, and Physical Research Laboratory. The fact is that when you look at the sun, one of the main problem is that when you go out into the atmosphere, the temperature starts increasing. So imagine that you have a fireball and you're going away from the fireball. You should be feeling that the temperature is going down because you're going away. But in solar physics or in the solar atmosphere, when you have the fireball, which is the sun itself, and going out in the atmosphere, the temperature starts increasing and reaches to 1,000,000 degrees. Whereas the surface is around 6,000 degrees and you are reaching 1,000,000 degrees. And that creates a physics problem that how does the sun manage to do it? So there have been a lot of studies, but one particular wavelength range, which is 2,000 to 4,000 angstrom, it covers the lower and middle atmosphere of the sun. And that has not been explored very much because, you keep learning and then think that, okay, that wavelength is interesting, so we should look at that because there is a missing gap and so on. And we decided to look at that niche area. The other scientific aspect of it is that while it will help us understand the temperature changes within the atmosphere, that wavelength range, the radiation in that wavelength range is important for the sun climate relation itself. At the same time, the radiation which is beyond 320 nanometers to 400, that comes down towards the earth, and that causes skin cancers and so on. So with this payload, we are aiming to look at the solar atmospheric dynamics, which has not been looked at before in detail. So we'll be able to manage with 11 different frequency channels in that. And that input will also help us understand that how much effect the solar radiation has in this chemistry of ozone and oxygen in the Earth's atmosphere.